exam break. When we do. Yeah. But we have the exam. We took like an exam for 8 weeks. Wait, what kind of days? I don't know how many. Last year we had 2 breaks. Not for 8 even. We have a break this week. And also didn't have a break. You had some exam where yeah. I passed that very much. And like I have micro this and then the next day I see but you yes. See? But when it's me early or the week in my oh my but at least in high school. Yeah, obviously yes, yeah, me too. You can use it.
Okay.
And so you guys can push.
These are the 4 main questions we did in Unit 7. We found a confidence interval for one proportion. We did a one proportion hypothesis test. We did a confidence interval for a difference of 2 proportions. And we did a difference of 2 proportions hypothesis test. Okay? This was 7.7, this was 7.8. So from 8.1 to 8.4 in this package, it's all of these again, except we replace the word proportion with mean. Okay, instead of finding proportions, we're going to be finding averages. So at the end of the day, there's going to be 8 of them. 4 confidence intervals, 4 hypothesis tests. Okay, so you have to do a couple of things. First of all, you have to be able to tell, is it a mean question or is it a proportion question? And the second thing you have to tell, am I asked to do a confidence interval or am I asked to conduct a hypothesis test? It should be pretty clear from the question. If it has the word mean in it, okay, you know it's a mean one. If it says do a confidence interval, obvious. If it doesn't say confidence interval, it's a test. Okay, so you can kind of eliminate things. So when we first started Unit 7, we did this. So to start this unit, we're going to do this, mean. Okay, and it's structured much the same way, except there's a little bit of a different formula for the standard error. Okay, and instead of large counts, we use large sample, like the central limit theorem. Okay, so it's actually easier because doing the large counts for these, it's hard to keep track of which ones you have to use, right? I think you've all seen that. Like this one, you use p hat. This one, you use p null. This one, you use p hat 1 plus p hat 2. This one, you use pc. Okay? You don't have to worry about that for means. Okay. So let's go back to the beginning. We're going to talk about YouTube salaries. Yeah. So let's say we want to find the average salary that a YouTuber makes. And how could we go about doing this? How could we go about finding the average and knowing that there's going to be, it could be a little higher than that average, it could be a little bit lower than that average. So we're going to make a confidence interval out of it. So this is what was done. So a search, how much do I make on YouTube? Found hundreds of videos in which YouTubers show off how much they make. Randomly sampled 35 of them. Okay? And from the figures shown in each video, estimated their yearly salary. And since these videos show their product channel revenue pages, we know the data is reliable. Recall back in Unit 6, remember we talked about how to do sampling distributions when we were given a population distribution. Okay? So just remember the difference between when we're talking about means now, the symbol, the Greek symbol mu represents the population mean, whereas X bar represents the sample mean. So population is a parameter, sample is a statistic. So going back to our example, we are interested in knowing the average yearly salary of all YouTubers, but since we can't do that, we're going to take a sample and find that average salary and hopefully come up with something pretty accurate to the population. Okay, and when we did Unit 6, how did we find the average of the sample means? Well, we took the population mean we were given. How did we find the standard deviation of the sample means? We took the standard deviation of the population we were given, divided by the square root of the sample size. Those are formulas we've already used. And that's what all these represent. Okay, so in this one, in this unit, sorry, in Unit 6, we use the mean and standard deviation of the population to figure out the mean and standard deviation of the sample. But that's not how it works in real life. Okay, we want to know the population, we only know a sample. So we're basically working backwards, but we use the same formulas. All right, so let's say we want, I'll get to t-distribution in a second. We're making a confidence interval for the sample mean. And again, it just tells you how 35 videos were randomly sampled, okay? And of those 35, here's all the yearly salaries. And the mean, if we average all of these out, we get $70,106 with a sample standard deviation of 82,188, which seems pretty high, which suggests that it's spread out, which you can really see by the dot plot that it is spread out. Okay. So X bar was 70,000. Yeah, so somewhere around there. So that was X bar. $70,106. And then our standard deviation, a measure of our spread, we just measure it from 0 to about here. That's about 82,188. Some other figures to keep in mind. The US, the poverty line in the US is 12,760. So where's that about? Somewhere here. The average wage in the US, just a little bit under 52,000. Okay, so reading other colors here. Oh no. Okay. 51,916. So we're looking somewhere around here. Average US salary. So we can just kind of compare it to the sample mean we got of 70,000, quite substantially over the US average and a lot over the poverty. So do you believe that it's likely the true mean YouTuber salary is exactly the same as the one in the random sample? You should know the answer to this by now. No. And what's the reason? Not standard deviation. Okay, we're just throwing out a bunch of statistical words. Say it again. What?
Sample variations.
Thank you.
Wow.
Right, and remember, sampling variation. Different samples produce different results. Okay, so how can we make a confidence interval? Well, let's go based on what we know. Remember, we have a point estimate and we have the margin of error. And the margin of error is made up of that critical value times the standard deviation. Okay? And the critical value is how many standard deviations we are away, depending on the confidence interval we want. Well, so we're going to call the population mean, we're going to say that the point estimate is the sample mean. The standard deviation, which when we're going from sample to population, we call standard error, is the sample standard deviation divided by the square root of the sample size. Okay, and just remember we call the sample standard deviation sample error. Sorry, the standard error. The standard error. When we go from population to sample, we call it standard deviation. When we go from sample to population, we call it standard error. Okay. So this is how we would set it up. Just a couple things to remember. Remember, this is our point estimate. These two being multiplied together is our margin of error. So in this case, our sample mean was 70,106. Plus minus, notice we want 95% confidence. Do you remember the value of Z star? 1.96. Used to be 2, but then discovered that I lied to you. No, I'm sorry. And then the sample standard deviation divided by the square root of the sample size. So if you calculate all that, you're going to get a confidence interval. It could be anywhere from, we are 95% confident that the true mean is captured by the interval 56 to about to just a little bit under 84,000. 83,998.31. Okay. That would make sense if we were doing it like we were approaching a confidence interval for a proportion. However, there is a problem doing it this way because we don't know the true standard deviation of YouTuber salaries. Okay, we only use the sample as in its place, which gives us a reasonable estimate. Okay, and because it's reasonable estimate, not perfect, there's some uncertainty involved. So we need a distribution besides the normal curve to account for that uncertainty. And we basically call it the T-curve or the T-distribution. The thing about the T-distribution, wider tails than the normal. So if you look here, the normal is in black. Okay, that's a normal distribution. I'll explain DF in a second. But notice when DF is a low number, do you notice that the T distribution is flatter and wider out at the ends, right? But then as it gets larger, this DF value, it gets closer and closer to a normal distribution, doesn't it? Okay, but still, even though it's got slightly wider, it's still got wider tails. And it accounts for that difference. Okay? So the T distribution is wider than the normal curve. And it captures the greater uncertainty. Okay? That's all we need to know for our purposes in this course. When we use the sample standard deviation, there's some uncertainty involved, the T distribution handles that uncertainty. DF stands for degrees of freedom, okay? How do you find the degrees of freedom in any problem? It's the sample size minus 1. And the higher the degrees of freedom, the closer we are to a normal distribution. But it's still not exactly the same as a normal distribution. And it basically measures how precisely the sample standard deviation estimates the actual standard deviation. So the higher the n, obviously, the higher the degrees of freedom, the more precisely we can estimate the actual standard deviation. Okay? And like I said, the higher the degrees of freedom, the closer we are to normal. So that says approaches normal. So instead of using Z star, the number of standard deviations in a normal curve, we're going to use T star. Which represents the critical value of the T interval. And it tells you how many standard errors to include in your interval. And it determines the confidence level. So the wider out we go, the interval gets wider, obviously. Okay? If we want to decrease our confidence level, then that's going to decrease the interval. So how do you find how many standard errors in a T distribution for 95% confidence. Okay? Well, remember, if you remember, when we found, the way we found 1.96, I'll just sketch this. Don't draw this. Don't draw this. So remember, we had 0, 1, 2, 3, -1, -2, -3. And if we wanted to be 95% confidence, that's 95% confidence, okay? With 2.5% here and 2.5% here. So we had to find this value and then make it positive. So how much was this? If this was 95%, this little area here is 2.5%. So if I want to find this value here, given the area, that's when I used inverse norm. But this time, to find the T value instead of the Z value, okay, we use inverse T. And that's, you find that at the same place in your graphing calculator that you do inverse norm. Okay, but just to answer this question here. Well, the critical value needs to be higher or lower. Well, because it has wider tails, it's going to be higher. Oops. Because the T distribution had wider tails, it will be bigger at 95% confidence than normal. And you could say that about regardless of the confidence. Okay? The critical value T star is always going to be a little bit bigger than Z star, no matter what the confidence level. And like I said, to find T, we would say, okay, I want to be 95% confident. That means I want to find this value here. And remember, if this is 95%, these two together represent 5%. So each one represents 2.5. So the area that I'm plugging into my graphing calculator is 2.5%, and it's going to give me the negative. So if you do this on your calculator, it will give you negative 2.03. Which is the same as positive 2.03. Because 2.03 standard errors to the left is the same as 2.03 standard errors to the right. So, at the end of the day, all we're doing is replacing this. We still use the other numbers that we have. Okay? So it's still going to be the point estimate mean plus or minus that 2.03 now at 95%. Sample standard deviation over the square root of the sample size. So our sample mean was 7106, plus minus, instead of 1.96, we used 2.03 to account for the greater uncertainty, times the standard error of 82,188 divided square root 35. And that will give us a more accurate confidence interval of just under 42,000, all the way up to just over 98,000. So we would say we're 95% confident this interval captures the true mean YouTuber salary. Okay, but I'll write that sentence when we do the state plan to conclude. Because again, like I showed you every other time, this is the long way. Now we want to do the quicker graphing calculator way. So just to finish this up, we're going to address the same problem with state plan to conclude. So state. What are we going to do at the state level? We are going to we will construct a 95% confidence interval for mean YouTube salaries. The plan, if you remember when we did a confidence interval, we used interval and we used Z. And it was one sample, right? So this one is, we will make a one sample T interval. For mu, which is the true mean YouTuber salaries. Okay. The conditions. Two of the conditions are exactly the same. Random, 10%. And remember, if you're doing an experiment, we don't have to do 10%, but these aren't experiments. When you have a one sample, it's not an experiment. To do an experiment, you need two samples. Okay. And then, and this is where it gets a little easier for means, large sample. Either we're told the distribution is normal or has to be greater than or equal to 30. And the sample size has to be greater than or equal to 30. Okay, so random, well, sample was randomly selected. We're told that. %, pretty safe to assume. 35, less than 10% of all YouTubers. And our sample size of 35 is greater than or equal to 30, which means we can continue. So like I said, a little bit easier to check conditions with the means than it is with the proportions. Okay, now we go to our calculator for the do. And again, it's under tests. So if you think about it, if you go to tests, or sorry, stat, then scroll across to tests, like you're going to see a whole bunch of them. Okay. Remember, we're looking for an interval, right? One sample, and it's T, not Z. And the only one that fits that is the one that's number 8, where it says T interval. So we're going to do T interval. Notice it doesn't say one sample, it just says T interval. So when you hit that, you'll see what you're asked to enter. So just stats should be highlighted. So just keep stats highlighted. Your sample mean. Okay, so let me write this down. Your sample mean, which is 70,106. Your sample standard deviation, which was 82,188. Your sample size, which is 35. And your sea level, remember sea level has to be decimal, not percent. So 82,188, 35. And we should get something very close to what we had when we did it the long way, and it appears that's the case. 41,873 to 98,339. Now I'll just write the conclusion. We are 95% confident the interval 41,873 to 98,339 captures the main YouTuber salary. Do you see a problem with how the sample was taken? Do you see potential problems with how the sample was done? Remember, they searched, did a Google search for videos of people who were advertising their salaries, right? Where's some potential bias in that?
The volunteers, like for higher salary.
Yeah, like if you had a low salary, if you were making 500 a year, would you be likely to make a video? No, probably not. Okay, if you're going to make a video, you're probably making some decent coin. So that's a potential problem with this, with the way that this was done. But we have an idea of how to construct the confidence interval. Okay. Good.